Alright, we are the hovercrafters. I'm Peter, I'm majoring in aerospace engineering.
I'm Charlie, and I'm majoring in biomedical engineering.
I'm Jeremy, and I'm majoring in mechanical engineering.
I'm Nick, and I'm majoring in aerospace engineering. So this is the engineering design cycle. It was the backbone of our project and how we were able to successfully build our hovercraft. For the ask part of the cycle, we did some research on real-life hovercrafts and just worked a way to scale that down to our purposes for the project. For the imagine part of the design cycle, we started making rough models on paper that we could translate to our materials.
For the planned portion of our design cycle, we messed around with a couple of ideas, then we went on to make a final design drawing. The picture below on the left is one of the ideas that we tried that ended up not working. And the picture on the right is what our final design looked like, except the base was rounded and made a little bit larger in the front for the final design. For the creation portion of our design process, we ended up having to make a lot of different designs for the base, because just making a base that let the hovercraft hover was definitely the hardest part of the entire project. The part of the design process that our group spent the most time on was the improving stage. Because of that, we had to make a lot of different bases for the hovercraft, and we improved those every single time.
One of the biggest challenges we faced in actually getting the hovercraft to hover was the geometry of the holes in the bottom of the skirt. We tried several different designs, big holes, small holes, medium holes. We tried 2 holes, and that didn't really work that well, and neither did like 4 or anything. We ended up just going with one large hole right in the center of the hovercraft, and right underneath where the pump was blowing air into it. We also had the problem of the hovercraft bouncing whenever you turned it on. So the way we finally solved this problem, which had been plaguing us since the beginning, was by making the entire skirt taut instead of loose. So before we had like a kind of loose bag under the skirt, and it would fill with air, and as it would release air, it would do it unevenly, and that would cause it to bounce. But when we made like a little rim around the edge, as you can see, and just laid the skirt taut so that the air would flow evenly out of it and allow it to hover better and more stably. Alright, so we ended up doing okay at FEDD. As you saw in the video, it would have actually been a really great time, except that it went off the edge right at the end due to lack of control. So we lost probably about a second or so there, and then plus the penalty for having to push it back on. So we don't know our exact time. We were told it was 5 seconds and some change. That's all they told us. We also don't know where we ranked, thanks to the excellent organization at FEDD this year. But we know we weren't last, and we know we weren't first. So we're somewhere in the middle out there. We definitely had probably the best poster at FEDD, and our hovercraft also looked very professional. But unfortunately, they didn't post all the scores for the hovercraft team, so we don't know where we actually ended up.
If we were to do the hovercraft project again, we probably wouldn't spend so much time on trying to get it remote controlled. And this is because at FEDD we noticed that the course was only a table length, whereas in the prompt it was stated to be a 40-foot long line. And so what we tried to do was hook up an Xbox controller to an Arduino board. However, we couldn't get the Xbox controller to hook up to the receiver, which connected to the Arduino board. So that idea ended up being a waste of valuable time. So we probably would have tested more with the hovercraft itself, trying to get it to work in a straight line so that it could just go down the table consistently with no problems. In addition, we probably would have explored onboard power sources that could power both the motors and the pump, so that we wouldn't have to press two separate switches or hook up two separate things in order to get it to work. Our advice to next year students who decide to take up the hovercraft project is try to meet more than once per week, just due to the difficulty of the project. We noticed that we were spending at least 4 or 5 hours per week towards the end, just because we only met once per week up till like the last month. In addition, we would also recommend doing all the research at home and making sure that each teammate is informed of what he or she is supposed to be doing during the next meeting and what the whole team should have done by the end of each month, just as a sort of way to track progress, to make sure that you will have a working product